The SAT asks us questions in a difficult way that is quite similar to what we've seen before. And they're asking us if these equations have no solution, what would the value of k be? And here's k right on here. What does that number have to be for these to be no solution? Well, we realize that we have two linear problems here. We have two linear equations. And this is hard to tell off the bat because it's not in y equals mx plus b form. And before I think about like, oh, how do I know I want to put it into that? It's because when they're saying that these equations have no solution, that means that we really do care about two lines that are not running into each other. No solutions means there's no intersections between these two straight lines. These are just two straight lines. And so what I want to do is understand them better by putting them into y equals mx plus b form so I can take a better look at their slope, and we'll see why that's important in a moment. So what I'm going to do is I'm going to rewrite this first equation and then the second one in y equals mx plus b form. So first thing I'll do is really what I want to ultimately just get y by itself. So I have negative 3y equals negative kx plus 4. I got that by subtracting kx from both sides, and I put that here. So that way the slope is where we normally would see it. Then I can get y by itself by dividing everything by negative 3. And then I'm actually going to put negative 3 here, negative 3 here. And then I end up with y equals positive k over 3x minus 4 over 3. Now there's a bunch of different ways to write up this expression, but this way here is going to be the most efficient for being able to analyze that expression. So then I'm going to do the same thing here on top where I have negative 5y equals negative 4x plus 7. Then I get y by itself by dividing everything by negative 5. Remember, you could divide this whole thing by negative 5, but because they're being added to each other and we're trying to analyze the slope and the y-intercept separately, I'd rather just then divide them separately as well. You can do that when they're being added to each other, the top terms. So this cancels out. Then I have y equals 4 over 5x positive plus or minus 7 over 5. And now I can look at these two expressions a little bit better next to each other. Like, all right, so what do I need them to be the no solution. What does that mean? I need them to be parallel. If they're not going to ever run into each other, the only situation that is that they're parallel. So they run next to each other, not on top of each other, but next to each other without ever intersecting, which means that their slope has to be the same. So what we need to do is we need this number. Let me actually highlight it in a different color. We need this number and then this number. I didn't expect the highlighter to be so big, to be the same. And it doesn't even look that way right now. So the best thing we could do is put k over 3 equals 4 over 5. What is it going to take? What do we need k to be for this to actually equal that? Well, we have two fractions equal to each other, and we can actually cross multiply instead of just like plugging in numbers and seeing if it works. So then k times 5, that's 5k. And then 4 times 3, that's going to give us 12. And then we can say that k has to equal 12 over 5 because we divide both sides by 5 to get k by itself. And we actually see that that is option A. This question comes up quite often, so I would recommend practicing it a couple times. Yeah, good luck.